A lesson now on the graphs of the sine and cosine function. If you were to go to Desmos or any graphing website or anything like that, and type in, instead of an algebraic expression like y equals 3x plus 5 or y equals x squared plus 2x plus 8, type in y equals sine x, right? And what you're going to see is just a line going up and down, right? If this is the x-axis, xy-axis over here, you're just going to see a line going up and down like this, and up and down and up and down like that. Right? If we go to Desmos, we could see that right here. Right? This is the graph of y equals sine x. Y equals sine of x. Right? This is what it looks like. Right? It doesn't look like much. Now, if you notice, one thing I did differently here in Desmos was I changed the x-axis. You over here under step, you can change the x-axis to not display values from 1, 2, and 3, but I'm displaying values of pi over 2, pi, 3 pi over 2. So I'm going up by half a pi unit each time you see a big grid line. And the reason I'm doing that is because that's how a sine wave or a cosine wave is really measured. Right? But again, the sine and cosine curves, this is the sine curve, and I'll show you what the cosine curve looks like. Let's see, it looks like this, cosine of x. This is called a periodic function. Right? It's called a periodic function. And the reason it's called a periodic function is because you're seeing this curve go kind of repeat itself after every certain length, and we'll talk about that, right? But this is the cosine curve. If you can follow the dot here, it's going to start up here at x equals 0. It's going to go down. It's going to go down to -1. Then it's going to go back up to +1. And then right here, right, if you were to look at the curve from 0 to 2 pi, you would see it travel in this manner, right? Again, starting at 0, 1, go down to -1 once it reaches x equals pi, and then once it reaches 2 pi, it goes back up to 1, and this thing is going to repeat itself from 2 pi to 4 pi in the same manner. Like so. Again, try to follow the dot. It goes down and then up. And then once it reaches 4 pi, it does it again. It does the same thing again. And it also does this to the left of the y-axis. If we travel from right to left now, starting at 0, we're going to see this go down, then back up, and at -2 pi, it's going to start up again, right? This is what a periodic function does. It does the same thing over and over again. Excuse me. And this sine of x is going to act exactly the same way, with the period and with the repeating. It's just going to act starting at the x-axis. Let's take a look, right? So over at x equals 0, it doesn't start up here at 1 that like the cosine curve does. It starts at 0. And then from here, goes up and then back down. Hits the x-axis once again, down below it, back up, and then over at 2 pi, goes back up to where it started, back to where it began. And then it repeats, 2 pi to 4 pi. Again, take a look at this curve. So in order to kind of really get a picture of what a sine or cosine wave looks like, all you really need to know is what one period looks like. It's called a period. So a period of a sine or cosine wave is going to be the distance of one full wave. Right, so which I'm drawing in black right now. Another thing that we're going to be discussing is something called the amplitude. And the amplitude is going to be defined as the distance from the top of the curve, not all the way down to the bottom, but from the top of the curve down to the middle of the curve. So right over here. And for this class and for this intro lesson, excuse me, the middle of the curve is always going to be at the x-axis. Right? It's going to making the amplitude pretty nice and easy to spot. Right? You could also think of the amplitude as the half of the distance from top to bottom. From all the way top to all the way bottom, you can think of the amplitude as half of that distance. Right? And I will have some notes for you. So this is what this is what a regular sine curve looks like. It's going to have, let's see, it's going to have an amplitude of 1, because it's going to go, the length of this line here is going to be 1. It's going to have a period length here of 2 pi, right? That's a horizontal distance of 2 pi. And it's going to follow this trajectory, okay? At the origin, it's going to travel up to the top, then down, crossing the x-axis once again, go all the way down this time, and then back up, and that's going to mark one full period, right? And that's how a sine wave is going to look. So really, this little snippet here is what the sine wave looks like. Now, I want to mention that for this class, the sine wave will always begin at the origin. Is that going to be true always? No, right? Because there is something called a phase shift, where this wave can get moved left or right, horizontally, right? But we're not talking about that. We're not going to discuss that, right? I want to let you know it's possible, but it's not going to be possible contained within this lesson and this class, right? That's something you'll learn later, maybe if you get to 1375. Right? So this is what a sine wave looks like. A cosine wave, again, like we saw, is going to still travel in the same period, 0 to 2 pi by default. That can change, and we'll see that change. It's going to have an amplitude of 1, again, because half the distance, like the full distance from -1 to +1 is 2 units, and half of that is going to be 1. Or you could say from the middle of the graph up to the top is 1 unit. But either way, that's the amplitude. So take a look at how the cosine wave starts, right? At the y-axis, it begins all the way at its peak at 1 and travels down all the way down to -1 and then back up. And once it hits 2 pi, again, the end of that period, you can see that the one full wave is complete, and beyond here, which is not shown, it's just going to do that again. Okay, and to the left of here, it does it again also, and it just repeats that over and over again. Now, the wave can look different if there is a negative sign in front of it, right? This is the graph for y equals negative sine x. Notice that, again, this starts at the origin, and it finishes at 2 pi, just like before. The amplitude is still equal to 1 because, again, the distance is a positive measure. The distance from the middle of the graph up to the top is still 1 unit, which means the amplitude is still equal to 1. But take a look, this graph is now traveling downwards to begin with, all the way up, and then back to where it started 2 pi units later. If you take a look at this is the graph of a sine wave. And quickly go to this is the graph of a negative sine wave. You can see that they are flipped and they are reversed. So let's go back. This is the cosine wave. Again, starts up here, goes down, back up. Take a look at the negative cosine. This is a negative cosine curve right here. Does not start up at +1, starts down at -1. Goes up all the way to the top, and then back down over to 2 pi. Right? Still has an amplitude of 1 unit, still has a period of 2 pi units. All right. So the amplitude and the period here. Let's take a look at these definitions. The default values, the default functions, y equals a times the sine of bx and y equals a times the cosine of bx, right? So instead of seeing just y equals a sine of x, we're going to see some values here in front of the trig function and also a coefficient attached to x. This a is going to measure the amplitude of the graph. The amplitude is going to be the absolute value of this letter a, right? Remember, once again, the amplitude measures a distance, which means it always has to be positive. Regardless of whether a is negative or not, the amplitude is always a positive number, right? So it's the distance from the highest point down to the middle of the wave. And the default value, if you don't see anything here, the default value is going to be equal to 1. Now this coefficient of x, which is denoted by the letter b, is going to stand for, it's not exactly the period, but it does factor into how the period is calculated. The period is going to be a formula of 2 pi on the numerator and then this coefficient b on the denominator. And remember, the period, the definition of a period is the length of one full cycle, one full wave of the sine or cosine function. And the default value, right, if b is equal to 1, that means 2 pi over 1 is equal to just 2 pi. Right, so let's take a look. I'll rewrite this. Let's take a look at calculating some values here. If we see something like this, one thing that I'm missing is this is incorrect. That should be an x, not a pi. Sorry about that. So y is equal to -4 cosine of 3x. The amplitude here is going to be calculated by the absolute value of -4, which is +4. And the period is going to be equal to not 3, but 2 pi over 3. And that's all there is to it. If you can simplify this, then you should. But since we can't, then we won't. And these are our values, right? Let's take a look at something else. I forgot to erase these, which is okay. Y equals 7 times the sine of, again, I forgot the x, so let's put that in. It has to be some kind of variable there. 7 times the sine of pi over 4 times x, right? So now the coefficient is equal to pi over 4. Sometimes this is written like so. Y equals 7 times the sine of pi x over 4. Right, but either way it's written, you should be able to identify that a is equal to 7, which makes the amplitude the absolute value of 7, which is equal to 7, and the period, 2 pi over b, is going to equal 2 pi over the coefficient of x, and that's going to be pi over 4, right? Even if the pi is the only one multiplied to x, the coefficient is everything here, right? So it's going to be pi over 4. And if it's written like this, it's a little more clear. So let's simplify this. 2 pi over 1 times 4 over pi. Remember, this is keep, change, flip, right? Because this is a complex fraction. The pi's can cancel out. And 2 times 4 is equal to 8. So that means the period is equal to 8 units. So if we see a graph, right, if we see a graph here that's given to us, right, how can we identify what kind of function it is? Now, once again, assuming that there is no thing called a phase shift that's going to be moving these graphs horizontally. Assuming that the phase shift is not possible, and that is what we are assuming right now, then we can identify a couple of things, right? From 0 to 2 pi, this is what we're looking at, right? This over here is kind of incidental. It's not important right now. What's important right now is the piece from 0 to 2 pi. We should be able to identify this as either a sine or a cosine wave. Now the key, because again, there is no phase shift, the key is looking at where this graph begins along the y-axis, right? This graph begins along the y-axis up here at 1, 2, 3, 4. This graph begins over at y equals 2, right? Over here we're marked that the top is equal to 5. So because this graph does not start over here at the origin, that means we can conclude that this is a cosine wave. And because we see the graph going up to 2, not 1, which is the default value, remember, that means we can conclude also that the amplitude is equal to 2. And concluding all this, putting all this together, we can state that the formula for this curve is y equals 2 times the cosine of x, right? Because we're seeing the standard wave happen from 0 to 2 pi, right? It's acting normally there. It's just going higher and lower than normal, and what's affecting that is the amplitude, not the value, the coefficient of x, not b. Let's take a look at this over here. Right, this is another curve. And what's important here is that we can identify, again, it tells us the scale. Each line is 1 unit long, so 2, 3, 4, 5, 6, 7, 8, 9, and up to 10. We're seeing a bunch of waves happening here. We're seeing a bunch of curves happening. So the first thing we want to identify right here is this a sine or a cosine wave? And again, because the phase shift is not possible here, that's going to be determined by where does this graph begin when it is crossing the y-axis. If it begins down here at the origin, it's a sine wave. And if it begins anywhere else, then it's a cosine wave, right? So because this thing is beginning at 1, right over here, that means this is a cosine wave. Also, this is a cosine wave that has an amplitude of 1, which is the default value. Now we could figure out, let's figure out the period, right? Because that's what's different here, right? If we look at the way one full wave happens, right? The cosine, remember, it starts up here, goes down, back up, and then once it goes back up to where it began, that's the completion of one full wave. So what we're seeing here is just on the right side, again, we don't need to look at the negative side over here. On the right side of the y-axis, that's 1, 2, 3, 4, 5 complete waves, 5 complete cosine waves. Right, so my question is, what is the distance from here to here? Because that is what your period is equal to. Right, it looks like, because of this scale, that looks like a distance of 2 units. So that means the period is equal to 2. Right, we can visually see that the period is equal to 2. Now, if we were to write the formula down, does that mean we're writing y equals amplitude of 1, so we'll leave that blank, cosine of 2x, right? Does that mean that the period, since the period is equal to 2, that the coefficient of x is equal to 2? Very common mistake, this is incorrect. Remember the relationship between the period and the coefficient and the formula. If the period's equal to 2, that means this formula of 2 pi over b turned out to equal 2. Right? That's very often forgotten when we're doing problems of this nature. So let's take our period that we measured, set it equal to our formula, 2 pi over b, and let's solve for b over here by cross multiplying. That's 2 times b is equal to 2 pi. Divide by 2. The 2's cancel here. The 2's cancel here. That means b is equal to pi. So our formula, our function, y equals cosine times pi x. Sorry about this. Let's erase all this. Let's combine everything now. Let's combine the two things that we learned. All right, because right now we're seeing, again, a bunch of different waves. We can ignore the left side. Right? We can focus on the right side. And the first thing we want to focus on here is sine or cosine. We're not looking at tangent or anything else, secant, cosecant, whatever. And we can look at where this crosses the y-axis. That's going to determine whether we're looking at a sine or cosine function. Since we're crossing at the origin, that means we are looking at a sine function. Next up, let's determine the amplitude. What is the amplitude of this function? 2, 3, 4, 5. We can see that from the middle, this thing goes up to 2, which puts our amplitude over at 2. Next up is the period. Now the period is going to force us to identify one full wave, right? So this is a sine wave, which means it goes up, then all the way down, and once it goes back up, and once it does that, we are finished. 1, 2, 3, 4, 5 units long for the period. So the period is equal to 5, and that makes that equal to 2 pi over b. Remember, this is the formula for the period, so we can figure out what b, the coefficient of x, is equal to. Cross multiply this. 5 times b is equal to 2 times pi. We could divide by 5b, cross those out, and then we're going to get here b is equal to 2 pi over 5. So let's put all this together in our formula so that y is equal to the amplitude times the trig function with 2 pi over 5, the coefficient of x, inside that trig function. All right. So let's look at, I'll erase this. I'll erase all this. Let's look at, from the start, a function like -5 cosine of 2x. We can identify the amplitude as +5. We can identify the period 2 pi over b is equal to 2 pi over 2. Right? So if we reduce this, we're going to get a period of pi units. Now if we wanted to draw a cosine curve, remember a cosine curve with an amplitude of 5 is going to start up at 5. Right, once again, sorry, let me start from the beginning. A normal cosine curve based on what I've drawn here. A normal cosine curve is going to look like this. It's going to start at 1, go down to -1 once it reaches the middle, then it's going to go back up to +1. Right? This graph doesn't do that. Why? Because this graph, first of all, has an amplitude of 5, which means it's going to start at 5, go down to -5, and go back up. right? So first things first, the amplitude does that. So is this the way the graph looks? The answer is no. Because the amplitude equal to 5, we've covered that. But remember, this is a -5 cosine, which means the graph does not do this. It doesn't start up at 5, it starts actually down here at -5, goes all the way up, and then back down. This is what the negative sign does. Remember, the negative sign does not change the value of the amplitude. The distance from the middle to the top is still the same, but it does flip that graph around, so it kind of looks like this. So is this the way the graph looks? No, because this is indicating a period of 2 pi units. Remember, that's the default. This graph has a period of pi units. So let's take a look. That means that one full wave doesn't go up top here at pi. It's supposed to do its completion at pi. So it's going to start up here and go all the way up and then back down, basically in half the distance that it takes to do it normally. All right, let's draw that better. Much better looking, right? Much skinnier. And then from pi to 2 pi, it does that again. So if you're asked to draw one full wave, you only need to draw this portion here, right? If you're asked, you might be asked to identify what this graph looks like from 0 to 2 pi or something like that, which in this case, it's going to be completing 2 full waves. All right, I hope this lesson was helpful. Thank you for watching.